Step 1 of our Rube Goldberg machine is the firing of a Nerf gun bullet from the Nerf gun which strikes the green ball, which falls off the box in Step 2. The ball is attached by a string to a pulley, which pulls the ruler in Step 3 forward, triggering the dominoes in Step 4. The dominoes strike the ball attached to the string off the edge of the box in Step 5, and the ball swings down like a pendulum and hits the marble out of the bucket in Step 6. The marble travels down and strikes the Hot Wheels car in Step 7, which travels down the track and hits the bricks, which fall in Step 8. Step 9 is the long brick falling and striking the first tennis ball, which then hits the hammer in Step 10, which strikes the second tennis ball in Step 11. The second tennis ball goes down the brick ramp and strikes the lacrosse ball pendulum in Step 12, which swings and strikes the pole in Step 13, causing the lacrosse stick to fall in Step 14, and achieving our final goal of releasing the ball from the pocket of the stick into the goal in Step 15.
The first key concept of physics in this Rube Goldberg machine is Newton's first law of motion. This states that an object in motion will stay in motion until acted upon by an outside force. This is demonstrated by the car hitting the brick, because the car is moving down the ramp until it hits the brick, which is the outside force. Next is Newton's second law of motion, which is explained by the formula F equals ma, or force is equal to mass times acceleration. This appears in our Rube Goldberg machine when the bullet hits the ball, because the bullet is applying a force to the ball and it contains both mass and acceleration while doing so. Newton's third law of motion also makes an appearance in our Rube Goldberg machine. This law states that for every action there is an equal and opposite reaction. An example of this is when the tennis ball hits the hammer. Initially, the ball is moving and the hammer is stationary. When the ball makes contact with the hammer begins moving and the ball moves in the opposite direction. Conservation of energy simply means that energy is neither created nor destroyed. Rather, it is conserved in different forms. For example, the bullet inside of the Nerf gun originally had only spring potential energy. When the trigger is pulled, the spring is released and the bullet then has kinetic energy. Conservation of momentum is the last key concept of physics in our Rube Goldberg machine. This just means that there is no change in the total momentum of the system. This is present when the ping pong ball hits the bucket holding the marble.